You're welcome to Waidsum Academy. Today we are looking at chemistry chapter 9, and the title of today's topic is rate of reaction. We're going to look at the effect of concentration, surface area, and temperature on the rate of reaction. Okay, without stretching, let's quickly look at some of the questions that needs to be answered in order for us to understand this topic. One of it is there are changes happening around us. We know that. For example, milk turns sour easily when you take it out from the refrigerator, put it outside. Unlike when you leave it inside the refrigerator. Inside the refrigerator, the milk will be preserved, but when you keep it outside, the milk will easily turn sour. This is one of the practical things that is happening around us on a daily basis. So this is a rate of reaction. We're going to find out what happened to the milk, why it turns sour later on in this class. And then why do you think chemists need to know how fast or how slow a reaction proceeds? Why do we need to know? Okay, why do we have to determine how fast the reaction is? So it's one of the things we need to get answer from the end of this lecture. And then the explosions and the ripenings of bananas and the roasting of iron and iron nails and the weatherings of stone sculptures are chemical reactions. All of these are chemical reactions. At the end of this, you should be able to understand what is the difference between a chemical reaction and a physical reaction. And then we're able to also arrange the reactions in terms of their rates, from the slowest reactions to the fastest reactions. So at the end of the lecture, you should be able to get these questions answered from understanding what you have done. Now let's take a look at the first part of this lecture. What are chemical changes? A chemical change is one that evolves or forms one or more new substances. So anytime a chemical change takes place, new products, new substances are formed. Okay, new substances are formed when chemical reaction takes place. So we're going to look at some examples, some reactions that involve chemical change, like fireworks. When you shooting fireworks, okay, when they explode, when fireworks explode, this is a chemical reaction, and chemical changes involve chemical reaction. Chemical changes involve chemical reaction. Number one. Number two, new products are formed. So these are two concepts you need to be able to say when you describe a chemical reaction. A chemical change involves chemical reaction. Number one. Number two, chemical changes, new substances are formed. Now let's take a look at an example, the roasting of iron nail. When iron rusts, new products are formed, right? New products are formed. The roasting is a chemical reaction. Then the decomposition of substances like hydrogen peroxide to water and oxygen. Decomposition of hydrogen peroxide to water and hydrogen. Also the decomposition of the thermal decomposition of calcium carbonate into calcium oxide, into calcium oxide, carbon dioxide, and probably one other product, right? If you write the reaction, if you write the chemical equation, okay? These are chemical changes. If you write the chemical, calcium carbonate decomposes into what? Into calcium oxide, decreases, or how fast the concentration of the product increases over time. So if you want to know, you take a look at how quickly the concentration of the reactor decreases. You know, when the reaction is taking place, the reactor will decrease. The reactor will decrease to form a product, right? They are forming a new product. So we measure the concentration of how fast the reactor decreases, or how quickly the reactor decreases, and how fast the concentration of the product increases over time. Now let's take a look at examples of it. That tells you the rate. How fast it dissolves in water, that tells you the rate. The speed at which the iron rusts. You know iron? When you leave iron in air, water, moisture touch it, air touches, and iron is eventually going to rust at which the rate of that reaction. Now let's take a look at factors that affect the rate of reaction. Meaning, what are those things that increases or decrease the rate of reaction? What are those concepts that will increase the rate at which a reaction will take place, or will decrease the rate at which a reaction will take place? Number one is concentration of the reactant. Concentration of the reactant. Concentration of the reactant. So what do we mean by concentration of the reactant? For example, assume I take a 50 centimeter cube of hydrochloric, the volume of water in a beaker. Let's say this is beaker A and this is beaker B. Okay, both of these, the volume of water inside is 50 centimeter cube. The volume of water or volume of the acid, let's say the volume itself. Volume is 50 centimeter cube. Okay, 39 seconds. Here, the time, 39 seconds. Here, 78 seconds. It takes 78 seconds for the magnesium ribose to be completely reacted in beacon B. But it took only 39 seconds for it to be completely reacted in beacon. So what the magnesium ribose is 5 centimeters here, and this magnesium ribose is also 5 centimeters here. Okay, it's also 5 centimeters here. Now, what changed is that we more particle of, so the frequency of reaction or collision of reaction is faster. So the acid is able to take on this one quickly and react with this one quickly and produce the product. Hydrogen gas is produced, magnesium, this is produced. So it's like you write a chemical reaction. You say magnesium plus hydrochloric acid. You get magnesium chloride, right? You get magnesium chloride and hydrogen gas. You get magnesium chloride and hydrogen gas. So we're going to measure the volume of, okay? We can collect this gas in a gas syringe. We can collect this gas in a gas, we connect the gas syringe to this beaker and collect the gas produced. So the volume of the gas produced determines the rate of the reaction. The volume of the gas, but the rate of reaction is equals to the total volume of the gas produced, over time taking for that reaction to have taken place. The total volume of the gas produced, okay, this is volume, not speed, okay? You know, in physics we write speed, or we say rate, which is like speed, is distance over time. But in this case, is volume of the gas produced over time taking for that to have taken place. So concentration, let's say a big cube, okay? If I take a big cube, let's assume this is a cube, okay, not a rectangle. Let's assume this is a big cube. This big cube, if you want a reaction to take place, it takes a longer time. Or you take a whole chicken. If you take a whole chicken, you want to fry chicken. You take a whole big chicken, put it in the fry pan to fry it. You take a longer time that you cut the chicken to small pieces and fry them. In less than 10 minutes or 10 seconds or few minutes, like 5 minutes, you've fried the small pieces of chicken. But the big chicken will take you a longer time. So which means if you cut any solid into smaller pieces, you have increased the surface area per unit volume. You've increased the surface area per unit volume. So the rate of reaction will be faster when you increase the surface area. What we mean by increased surface area is that same substance, cut it to smaller units. Like this magnesium ribose, if you cut it to small tiny pieces, the reaction will even happen lesser than 39 seconds. The reaction will be faster when reacting with acid. It will complete maybe less than 20 seconds. Pieces, if you cut it to smaller pieces, you have increased the surface area of that concept. You've increased the surface area of the solid. So, meaning cutting it to smaller pieces has increased the rate at which the reaction can take place. So that's not. And then another factor that affects the rate of reaction is the temperature. Temperature is actually like when you increase temperature, like temperature is at 20 is different from temperature at 60 degrees. When you increase temperature, what happens to the particles of the reactor? The particles gain more kinetic energy. So when the particle at 60 gain more kinetic energy compared to particles at 20, they gain more kinetic energy and they're able to, the momentum increases, the rate of collision increases. If you look at collision theory, the rate of collision increases, the rate at which the reactive particle will overcome the activation energy is faster, so the reaction occurs very fast. Okay, so temperature increases the rate of reaction. But they are not only limited to these three factors. Okay, there are other factors like increasing, in case if it's a gaseous reaction, increases the pressure. The pressure of the gas will increase the rate of reaction. So let's add pressure to it. Increasing the pressure, the momentum of colliding particle would have increased. So as a result of that, but it does not have much effect on solid and liquid. But this one has effect. This factor has effect in gaseous reaction. So when a gaseous reaction is taking place, then the increasing pressure increases the rate at which the reaction will take place. Now, it doesn't stop at this four. Let's add another one, the fifth one. Let's say using a catalyst. Okay, if you use a catalyst, it will speed up the rate at which reaction will take place. Why is that? Because catalyst will lower the activation energy. Catalyst will lower the activation energy, speed up the rate at which reaction will happen. So this is at which reaction takes place. Now let's move on to the factors themselves now, looking at it diagrammatically. Okay, factors affecting the rate of reaction. They've all been listed here. Concentration of the reactant, concentration of the reactant, pressure of the gaseous reactant, pressure of gaseous reactant, okay, pressure of gaseous reactant, temperature of reactant. I just mentioned, okay, although this is not so clear, they're just giving you some rate of reaction. Reactions that are fast, like okay, like rusty, okay, rusty. Those ones are very slow. Those ones are very slow. Okay. Now here are what are the effects of concentration. Now we are taking them one by one. I think I have explained all of this. What are to happen? This table shows the different concentration effect on the rate of reaction. Let's take a look at this one. Say more concentrated acid, beta A, what happened? Beta B, what will happen to the rate of reaction? Faster rate of reaction. Reaction will happen faster. Okay, let's take a look at collision theory. Okay, why I will just move on. I have also did it capture all of them. I've already explained them. Now let's move to 9.4 because it just jumped to. Now in collision theory, the collision theory states that the reaction happens when the particle collide with enough energy. If there are no enough energy, it will take place. Then another point is that the faster, the more frequent collision, the faster the rate of reaction. The faster and the more frequent the collision of particle happens in a reaction, the more the reaction, the faster the reaction will be. The faster the reaction will be. Now, when the collision of particles, when the collisions between the reactant particles fulfill these two conditions, meaning they have enough energy for it to happen and they're happening very more frequently, then when this happens, they fulfill these two conditions, then the product particles are formed. Then that's when the product will be formed, like this one. That's when the product particles will be formed, when these two conditions are met. Okay, now these collisions are known as the effective collision. The collision that occurs, the both of them hitting the faster rate of chemical reaction. Higher frequency of effective collision will result to faster rate of a chemical reaction. Now let's take a look at this example. How does the concentrations of reactants affect the rate of reaction? Okay, using collision theory this time around. Now, if you take a look at this one, you see that we have fewer. If we increase surface area, the rate of reaction. However, if you cut this solid into smaller tiny pieces, if you cut it to smaller tiny pieces, what will happen? If we cut this solid to smaller tiny pieces, what will happen? The rate of reaction will happen faster. The rate of reaction will happen faster here. Why? Because this other particle can easily react with this one because they are smaller in size, can easily react with this one, and then the rate of reaction is faster. So when you increase surface area, the rate of reaction happens very quickly. How does the temperature affect the rate of reaction? Temperature.